This is the original USB to 4-port adapter I have used in my system. It connects 4 Victron devices to one USB port. And look at all these insects underneath this clear heat shrink. Because there are lights on the PCB, they get attracted and then they get in through these tiny holes here in between and get stuck. And back then this was also an option. Also USB to 4 times Victron. But this one has the original JST Victron VE.Direct connectors. And this is what I'm using right now. But they don't make this version anymore. So what they are making instead is this. Wow, that's a new one. That's the first time I'm seeing one myself. And this new model now has again the VE.Direct connectors. JST, whatever it's called. I've got USB-C in and 4 individual and isolated VE.Direct ports to connect your Victron VE.Direct devices. Ooh. We've got status LED for the USB connection and then TX and RX for each of the ports. And this is also a new feature. We now can turn off the lights. If you have this one installed in an RV or in a cabin or something and it's not covered, it looks like in a disco then. So here's the option now to toggle these lights. Beautiful. And here with these ports you can make your own VE.Direct cable with a JST connector, plug them in and you're ready to go on the other side for your device. By the way, you can get these cables here on the DUPPA website as well. They make them from 0.5 meters over 1 meter, 2 meters, 5 meters and 10 meters. And if you already have the overpriced original cables from Victron, they of course fit as well into this converter. If you put them the correct way around, there you go. Each of the port can handle 1.8, 3.3 and 5 volts independently, because some of the Victron devices, the MPPT solar charge controllers, they use 5 volts on the VE.Direct cables, while the Smart Shunt, for example, uses only 3.3 volts. With this device, no problem, plug in whatever you like. Yeah, this little table here is a bit missing on this device, unfortunately. There's lots of space, Simon. And because we've got screws here, I want to have a quick look inside. And see how clean the PCB layout looks. Ooh. Here we've got the original FTDI chip and you can see the isolated converters down here. Probably the power supply in the middle and 2 more controllers here in the top left. Yeah, looking good. Alright, let's put it back together because we want to install it now. And as always guys, all these links to these converters, adapters, the cables in different lengths is all under the video. So thank you Simon Caron from Torino, Italy. It is Torino in Italia, the land of the pizza and red wine. Yeah, thanks for sending all this stuff over. And guys, this is no advertising. I'm using these converters here for years because the Raspberry Pi doesn't have any VE.Direct connectors at all. 0. But here with these converters, as many as you like. Guys, this is Andy from the future, from the end of the video already. I have totally forgotten to show this device either. Yeah, this is a USB to VE.Direct converter, but a single channel. But it has the same features as the quad channel converters. Isolated input to VE.Direct, USB-C. And this is exactly made with the same great quality as the quad converters. And especially if you want to connect one more VE.Direct device to your system and have no ports left, there's your solution. Alright, as you can hear, it has started raining. Okay, back to the video. Welcome back once again to the off-grid garage here in... It is raining. We've got only 23 amps outside. It's not good. Made only 23.8 kilowatt hours today. And already charged the vehicle. Well, it's good. I've got another 148 kilowatt hours stored in the batteries. plenty of stored sunshine left. Yeah, and in today's video we want to do some do-it-yourself work here on the battery shelf, a bit of an upgrade. You can see there the DUPPA 4-port USB to UART adapter working. And look at these lights. Why would you turn them off, right? When I installed this one here, I was actually considering putting this somewhere over here, so the LEDs actually light up the room. And this is actually something you should consider. Putting this USB adapter somewhere over here, for example. Yeah, and then you have very short runs of the VE.Direct cable to all your 4 MPPT controllers, for example, and only one USB connection from here back to your GX device. So yeah, you could mount it upside down, drill a few holes there in the cable duct and have all your VE.Direct cables going directly to the MPPTs. Then you can enjoy the lights all the time. And if it gets too much, you just turn them off. We want to definitely leave them on. So yeah, there it is, the Raspberry Pi running the Venus OS. Since we did the upgrade with the flexible SD card holder and the fan and this acrylic case here, I haven't had any issues anymore. It seems to stay cool, the SD card doesn't get as hot anymore. Lasts already over 2 years. I should probably do a backup, just in case. So all 4 USB ports are in use here on this Raspberry Pi. We've got one going to this 4-port UART controller. We've got one USB connection going into the MK3, connecting the Multiplus 2. We've got this beige cable there. This is a USB extension. This goes all the way somewhere over... Yeah, there it is. There it is. That's where I stopped. And then a USB to VE.Direct adapter plugs in, which connects the Phoenix back to the Raspberry Pi. And I actually want to get rid of this connection inside this cable duct. So we will install a VE.Direct cable directly from the Phoenix inverter through the cable duct back to the Raspberry Pi, which will then use one of the ports of this 4-port converter. And the last port is being used for a USB to VE.Direct adapter again, which goes to our smart shunt here. So everything is plugged in at the moment, but now I want to connect the second smart shunt, which will eventually live over there somewhere. But for testing purposes, it is still connected to the Powerwall 2.0 and measuring voltage and current, ampere hours, everything going into these batteries. And you can see this one is also connected with a VE.Direct cable, but not to the Raspberry Pi, unfortunately. It is connected to the Zerbo GX over there of the SPAT calibration center or the Powerwall 2.0 here. So at the moment I'm only measuring the energy going in and out of the battery shelf with this smart shunt here, and this is what Victron uses to determine the state of charge. It doesn't know anything about the second smart shunt, of course. So the task for today is getting rid of all these USB connections here, and that's why we need this new device, because it uses only one USB port, and then we can connect 4 more Victron devices through VE.Direct. Yeah, and even if you have a Zerbo GX, you have only 2 VE.Direct ports and 3 USB ports. So you are limited to 5 devices altogether, which could be sufficient for a small system, but here with my system, it wouldn't be enough either. So unfortunately, I cannot replace the MK3 adapter here. This needs to stay. So 1 USB connection for that, 1 USB connection for the existing quad connector, the 3rd connection for the 2nd quad connector, and then we've got 1 USB free. We probably need this at some stage for the Cannibal USB to CAN adapter. And this is a plug-and-play device which just plugs in via USB to the Raspberry Pi. Nothing to install. It works out of the box. I'll link this also down below. So if you want to upgrade your Raspberry Pi with Venus OS with CAN communication, you can use this plug-and-play Cannibal adapter. Instead of one of these CAN heads you can put on top of the Raspberry Pi, but then it wouldn't fit in such a case anymore. And the advantage of this adapter is it is plug and play, you don't need to install anything, while if you have a CAN head, you need to install the driver for it manually on the GX device. So yeah, this CAN adapter is unplugged at the moment because we don't need it. And as you can see here in the battery shelf, I don't have the IBMS installed anymore. I have recently left the project for various reasons. So at the moment we don't need the CAN port anymore, but we will be very soon again. I can unplug this one, which is the VE.Direct to USB adapter going to the smart shunt. We don't need this one anymore. So we can unplug the other side as well and can pull this one out. Alright, let's see if we can pull out this VE.Direct cable to the Phoenix inverter. I need to take this one off. There you go, there's our on-off switch, which I can use to manually turn on the Phoenix inverter. We have installed this in a past video. And there's the VE.Direct cable. So I'm going to unplug this one and take it out of this split loom, which only goes until here anyway. This is something we have used in the past. These were the original adapters we have used. They are not isolated and they're ending in 4 separate wires. And then we bought these ones here separately to connect them together, but not isolated. Not good. That's what we did in the past, right? Alright, and then we need to pull out this extension USB cord as well, which I assume is in this duct here. And this will be nasty to take off. Got it. I'm not sure if I should take this off. Yeah, it comes out over here in the corner. Very difficult to reach. Okay, I have to do it to pull through the new cable. There it goes. Here's another piece. Okay. I have worked in pieces here. These are probably all the offcuts. And I've used them behind the shelf here so nobody sees all the joints. Need to use the camera display to see what's going on. So in the past I was able to slide the cable duct all the way out of the battery room, but now everything is closed. I cannot do this anymore. Alright, I need to get the ladder in here to get better access. Got it. Alright, this was a bit of work to pull this USB cable through this clamp because of the fairly large plug it has. And I probably pulled in the USB cable first and then all the other thinner cables here. There's the network cable going to the Multiplus and also the 4 VE.Direct cables to the MPPTs. This all goes through one clamp. But I managed. So now it is just a matter of pulling this through. There it is. Victron VE.Direct cable. USB extension cable. Gone. Yeah, pulling out cables is always the easy part, right? So now we need a cable from there all the way through here, through there, and back to the Raspberry Pi. Also another VE.Direct cable from here all the way up there, back to the Raspberry Pi. And another one from this smart shunt there, back to the Raspberry Pi. When I say Raspberry Pi, I always mean this quad connector, of course. And the non-isolated VE.Direct connector. So now we've got 2 meter, 2 meter, 1 meter. I think for this one I need a 2 meter length. And then here we need to make one. We need to join 2 meters together to go from there through the cable ducts back to there. And here we have 1.4, 2.4, 2.4 and a bit. So 3 meters are actually long enough. And that's perfect. So we can keep this one for the shunt and these two are being joined together. And I already have a 1 meter length here from this smart shunt back to the Pi. No, to the converter, of course. Do we need some solder, heat shrink, Miss Piggy. Okay, we probably... I'll leave a bit of cable on this off cut because then I can reuse it if I need to make another one. Yeah, let's do it like this. And this is only non-shielded, non-twisted cable. Do the same over here as well, a bit of cable left. So we can make a very short VE.Direct cable, look at this. Alright, and now it's just a matter of matching these colors together, a bit of heat shrink, and we are done. Time lapse. That's it. Custom made 3 meter VE.Direct to VE.Direct cable. Alright, it's in. Okay, now you use this split loom again to hide the cable. That's where the joint is then. Can you see that still? Not really. You're looking in the wrong direction, guys. This is where the joint is. It is in this nice straight duct. So I'm really trying to stay under these DC cables here because we have to leave. Look in the wrong direction again. Because we have to leave the main duct again to go into this small one. Oh, it looks quite short. I think it just fits. Just. So let's see if we can make it work. Alright, now it goes into the gland. It is inside the box, which is good. The only question is how much space, how much length do we have? Okay. It looks like it's especially made for that. That's all the length we have inside the battery shelf here. Perfect. Okay, I'm trying to get this VE.Direct into the smart shunt. Oh, it's already in. It's so easy. I shouldn't even talk about it. Okay, this goes behind there. All the way behind here. Alright. And this is and this is once again exactly made for this length. Look at this. They're both sitting here with the same length left. Just made for it. Alright, this is all done. We just need the second smart shunt now. And this should be fairly easy because we've got a 2 meter. If you want to do it correctly, we have to go down here into the cable duct, go all the way up there into the cable duct and then over there. But this is just a temporary setup, so I'm not doing this. We just loop this around and I'm not telling anyone. There's also a rubber sealing inside the gland, which I really should have removed back then. And now through the actual gland, and we should come out somewhere there. Ah, there it is. Beautiful. All right, I make this the same length as the other two, which is roughly like this. And then we can close this gland again. Definitely a job for 2 hands. I don't know how to get all these lids back on these ducts. This will be the biggest challenge of this whole task, I guess. But we will worry about this later. All right, so we've got all these ones connected and we've got 2 USB ports free now behind these ones. I'm not unplugging them because sometimes they get a new ID and this messes up all my stuff in Home Assistant. All right, let's plug in this USB port. Come through here and plug in the 4-port quad connector. It doesn't work. Doesn't work. Because the switch is off. Okay, turn it on. Yeah, we've got a light. We've got power. Big shed, carport, garage, east, garage, west. We've got this twice in here, okay? Multi-plus, Aura charger. Smart shunt not connected. Phoenix inverter not connected. Tesla wall connector is connected and the till system is running. Okay, let's plug them in. That's probably the main part why you're here, right? Okay, this one goes here. This should be the Phoenix inverter. Oh, I'm not even sure. I don't even know which one is which. No, this is the smart shunt power wall. There it is. That must be the Phoenix. Takes a few seconds. The Phoenix won't be showing anything because it's not turned on. And then we have, all right, this should be the smart shunt. Smart shunt. See, it's in there twice now. Okay, we could potentially even mount this one here somewhere in the box like this or so. Double side sticky tape or whatever. You know, mount it here, bang. It's out of the way, looks good. You can see the lights. Yeah, all right, keep this as an option. Oh, has the bottom fallen off here. Very good, very good. Look at this, we've got now a 7 plus 1, which is free still, 7 VE.Direct connections at the Raspberry Pi, which has usually none of them. That is so good. That's it with any sunlight for today. Look at this gray mush, cloudy weather there. But anyway, guys, we have finalized the task for today. I'm very happy about this. And we have installed the second quad converter to USB for the Raspberry Pi. I'm connecting 7 of the 8 possible VE.Direct devices directly. So that's fantastic. So in theory you could connect 16 VE.Direct devices directly to the Raspberry Pi with an active USB hub, even more. And who's got 16 VE.Direct devices, right? I mean, who's got 25 batteries? Alright my friends, as always, thank you so much for watching. Thanks for all your amazing support here on the channel. Special thanks goes always out to the people who are donating to the channel, buying me a beer, a spat, a smoothie, becoming a channel member. Thank you very, very much for your contribution. As I said, I link all the information about the Quad VE.Direct to USB adapters down in the video description. Fantastic devices with isolated, separate inputs. They can handle everything from 1.8 to 5 volts. Separately, individually. Amazing. And the most important thing is, look at these beautiful lights. Guys, thank you for your support. More videos are coming soon. Leave a nice comment down below and a like. If you are new here, subscribe. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. But wait. Now we've got 2 smart shunts on one Victron system. That doesn't make sense. We know only one can be the battery monitor. The other one basically doesn't count. And I will show you exactly a solution for that problem in the next video. So stay tuned.